Year 10 Acceleration Lesson 1. What we're going to do in this video is learn how to calculate acceleration from one of the acceleration formulas and then see how that applies to a velocity time graph. Alright, we're going to start with a quiz. So the first thing I want you to do is press pause on your video and do this quiz. Give yourself about 5 minutes. Press pause now. Right, the answers. Number 1, meters. Number 2, seconds. Number 3, meters per second, m/s. Number 4, you could have had force equals mass times acceleration. You could have had acceleration is change in speed divided by time. That's what this lesson is about. If you've got the physics equation sheet handy, you might have found v squared minus u squared equals 2as. And that's going to be next lesson, so we'll leave that alone for now. Number 5, a scalar is a quantity that only has magnitude. Now, magnitude is only a fancy word for size. So if I say a scalar only has magnitude, I mean it's just got size. Examples of scalars are things like energy, temperature, speed, distance. Those have all got numbers associated with them. They can have a certain size, but they don't have a direction. Number 7, a vector is a quantity that has a magnitude and a direction. So it's got size and the direction matters. So for number 8, examples of vectors, you could have said force, weight. Weight is a force, so that's a vector. Velocity, momentum, acceleration, and there's a few others. If you're not sure, ask Google. Number 9, what's the difference between speed and velocity? We've pretty much covered that in the previous questions. Speed is a scalar, velocity has a vector. So velocity is speed with direction associated with it. So 30 miles an hour is a speed, 30 miles an hour north is a velocity. And number 10, an example where your speed is constant. You could be driving round and round in circles on a roundabout at 10 miles an hour, but because your direction is always changing, your velocity is not constant. Your velocity is changing. Anything that's going around in circles will give you a constant speed but a changing velocity. So satellites orbiting the Earth, the moon orbiting the Earth orbiting the sun, they all have constant speed but a changing velocity. Okay, let's move on. Acceleration is sometimes called the rate of change of velocity. It's just a measure of how quickly velocity is changing. So if something's speeding up, its velocity is going to change. If the velocity changes a lot in a very short time, then it's got a high acceleration. If it changes very little in a long time, then it's going to have a very small acceleration. So the equation is acceleration is change in velocity divided by time taken. I prefer using symbols to words because it takes up less space when I'm doing my working out. And the symbol version is here. We use A for acceleration, V for final velocity, U for initial velocity, and T for time. Now the reasoning behind V and U, I remember V stands for velocity, U comes before V in the alphabet, so U must have been the velocity you started with because it comes earlier. And the units are meters per second squared. Now the squared in the unit, that's just part of the units. You don't have to use the square button on your calculator for any of this equation. I'm going to talk you through 2 worked examples. If you think that's fine, I'm good at maths, I don't need to be shown, then by all means stop the video, have a go, and then play the video to check if you're right. Okay, the first thing I'm going to do is underline all the data we've got. Now we've got some hidden data. It says a racing car accelerates from rest. If you're at rest, it means you're not moving. So we've got the initial speed, the initial velocity is 0. It ends up at 60 meters per second, so that's the final velocity or the final speed. We've got the time and we're asked for the acceleration. So I'm going to list the data there. Then, next step is to write down the equation and substitute in the numbers that I know. Now the brackets are important here, make sure you don't miss them out, especially make sure you put the brackets in if you're using your calculator. So if I work that out, if I do A equals 60 minus 0 divided by 4, I get 15, and I'll remember to write down the units, meters per second squared. Next one, a cheetah spots a gazelle. You find lots of context around these questions, but honestly, when I'm scanning this, I'm just looking for the data, which is why we underline and box what we want to find out, because the context is not important. So here we go, we've got the acceleration from rest, so we've got the initial speed is 0. We've got the final speed, and we're asked how long did this take? Well, that's the time. So there's my list of data. There's my equation and my substitution. The reason we do that is that you get a mark for writing down the correct equation, and then you get a mark for substituting the data into that equation correctly. If you rearrange it wrong, you'll lose the mark for substituting. So get into the habit of doing it this way around if you can. Okay, that gives me 10 equals 20 divided by t, so 10 times the time must be 20, so the time must be 2 seconds. Okay, I want you to pause the video and do these 6 questions. Give yourself a couple of minutes for each one. Make sure you paused. All right, here's the answers. Okay, so you might notice in some of these questions that if you don't use the brackets, your calculator might tell you the wrong answer. For example, in question 2, if you got an answer of 3.16, then you didn't use the bracket buttons in your calculator correctly, so have another go, but this time put the brackets in. Same idea with number 5. If you got an answer of 17, it means you didn't use the bracket buttons correctly. So try again, but put the bracket buttons in. Okay, if you want more practice using the formula, then pause the video, download the worksheet activity 1 and mark it using the answer sheet. Page 1 is questions and page 2 is my worked answers. If you think, yep, I got all those 6 questions right, I'm fine with this, then you can skip activity 1 if you want, or you can save it for your revision later on. Next thing we need to be able to do is calculate acceleration from a graph. Now the gradient of the line on a velocity time graph is the acceleration, and the gradient can slope 2 ways. It can slope up or it can slope down. If it's sloping up, velocity is increasing, therefore we've got acceleration. If the line is sloping down, like in the second graph, the velocity is decreasing, so we have deceleration. So you might find that some of your answers will give you negative numbers. That just means that the acceleration is negative and we're getting slower. So have a look at this graph. We're going to work out the acceleration between points A and B. Now, although we need to be aware that the acceleration is the gradient, rather than actually working out the gradient on the graph, I'm going to show you a different way of doing it that saves any confusion. I'm just going to use the graph to take the data, and then we're going to use the equation. So the velocity has increased from 5 meters per second at point A, if you look at the velocity axis, up to 25 meters per second at point B. And that took between 2 and 6 seconds, that took 4 seconds to happen. So the acceleration is the final speed minus the initial speed divided by the time. That's a change in speed divided by the time. 25 minus 5 divided by 4 is 5 meters per second squared. And you'll notice I'm making sure I'm putting the units in every time, because this is one of those units where there's quite often a mark for knowing it. Okay, pause the video and work out the acceleration for each of these graphs. Gives yourself about 5 minutes. Are you ready for the answers? Here we go. So the first one's fairly straightforward. The second one and the fourth one, I've deliberately left my mistakes in. And this is why it's very important to do that list of data when we do these problems. It's very easy to get your U and your V the wrong way round and end up with an answer that's positive when it should be negative. Okay, moving on. Here's a more exam style question. Now again, I'm going to talk you through this one. But if you think, yep, I'm going to have a go at this, that's fine. You go ahead, pause the video and have a go, and then play it to check your answer. Right, part A. What's the cyclist's velocity at 40 seconds? There we go. Find 40 seconds on the graph. Read up, read across. 4 meters per second. B, during which part of the race is the cyclist decelerating? There's only one part. We're looking for a line that slopes downwards. And we'll say from 100 to 120 seconds. What's the cyclist's acceleration between 60 and 80 seconds? Right, we're working out the acceleration. They've given us some information here. So find those 2 points on the graph. Examiners love it when you annotate graphs. It lets them see how you're thinking. So the initial velocity was 4 meters per second. The final velocity was 8 meters per second. And the time was 20 seconds. Even if I do nothing else, I've got a mark already because I've shown I've used the graph to get the data. Next thing, write down the equation. That gets you another mark. Substitute the data correctly. There's another mark. And work it out to get you another mark. So these are worth a lot of marks, typically about 3, 4, even 5 marks for something like this. Here's another one I'm going to talk you through. Again, if you're confident, pause the video, do it yourself, and then play to check your answer. Okay, negative acceleration, that's where we have a line sloping down. And that's from 70 to 120 seconds. Next one, calculate the acceleration between 30 and 40 seconds. Show clearly how you work out your answer and give your answer in meters per second squared. They've told us the units, so there's no mark for this, which is why it's 3 marks and not 4. Right, find the points on the graph. Write down the information. Write down the equation, substitute in the data, and work out your answer. Okay, I want you to pause the video now and do activity 2, the graph skills exam questions. And then when you're done, play the rest of this video and you can self-assess your answers based on my model answers. Okay, speed time or velocity time graph exam questions. Now question 1 is relatively simple. I think it's a foundation level question, so it shouldn't have given any of you too much trouble. First part, choose words from this list to complete the sentences below. Part A of the graph, here we go, part A is speeding up. Part B is a steady speed. and part C is slowing down. Okay. Next part, calculate the acceleration of the runner during the first 4 seconds and show your working. Okay, so the first 4 seconds is from here to there. We've got the initial speed is 0, final speed is 10. So if I summarise that information on the question, calculate the acceleration during the first 4 seconds, time is 4, u is 0, v was 10 meters per second. That all came from the graph. Good idea to annotate the graph. So if I use the equation, acceleration, final speed minus initial speed over time taken, or you could say change in speed divided by time, and well, change in speed is obviously 10, you can do that in your head. So that would be 10 divided by 4. I'm going to continue using the equation all the time because the equation always works. Sometimes doing it in your head, if you're me, doesn't. So v minus u, 10 take away 0, remember my brackets, divided by time, so that's going to be 2.5 meters per second squared. Question 2. So this time I've got a velocity time graph for a cyclist. The context doesn't matter very much. Gives us some information at the start. Accelerates at 1.2 meters per second squared for 5 seconds. Okay, but doesn't tell us to do anything with that yet. So there's our graph. We can see velocity increases, velocity still increases but not as much, constant speed for a little while, and then velocity decreases, decelerates again. The velocity includes both speed and the direction of the cyclist. Why has the data for the cyclist been shown as a line graph instead of a bar chart? Line graphs are for continuous data, bar charts are for data that is discrete or ordered or discontinuous. So both velocity and time are continuous data. It's possible that you'd get away with just writing it's continuous data because it's only 1 mark, but it's good practice to use words from the graph. So I've used the words from the graph labels. Calculate the acceleration during the first 5 seconds. That's a little odd because they've actually told us the answer up there. Okay. I guess they're asking us to prove it, so we know the answer before we get there. Because they've told you up at the top that it's 1.2 meters per second squared, you're not going to get any marks if you just write down it's 1.2 meters per second squared because you told us. Okay? You actually do have to show your working for something like this. So, for the first 5 seconds, that's up to this point here. So, annotate the graph. Prove that you've used it. So for the first 5 seconds, you can read up and then read across and say, okay, time is 5 seconds, initial speed is 0, final speed is 6. So let's put that down here. You can say u is 0, v was 6 meters per second, time is 5 seconds, the equation, then substitute in the numbers, I didn't have to write the units because they've given it to us. So the marks there are for getting the equation, getting the values from the graph, knowing the equation, and being able to substitute in the right way around. Calculate the deceleration between 30 and 40 seconds. Okay, I can already write down it's between 30 and 40 seconds, so time is 10 seconds. I need to get everything else off the graph. So at 30 seconds, we're up here. I should really use a ruler for that. So I know that u equals 9 meters per second. At 40 seconds, v equals 0 meters per second. Time is 10 seconds. So let's transfer that down here. U is 9 meters per second. V is 0 meters per second. A equals V minus U over T. So A equals, got to get this right way around, 0 minus 9 divided by 10 minus 0.9 meters per second squared is given to me. Question 3. Another velocity time question. Describe the motion of the racing car during the period labelled W. Well, if we look at the graph, we've got some acceleration, we've got some greater acceleration, we've got some steady speed, and we've got some deceleration. Describe the motion of the racing car during the period labelled W, accelerating. It's only 1 mark, so I don't have to give any more detail really. I could work out, well, it increased its speed by 10 meters per second in 2 seconds, therefore the acceleration is 5 meters per second squared. But that's going overboard for 1 mark. Won't do you any harm. Next one, the period labelled Y. That's this bit up here, where we've got a horizontal line, steady speed of 50 meters per second. Or I could have said constant velocity of 50 meters per second. Calculate the acceleration of the racing car during the period labelled X. Show clearly how you work out your answer and give the unit. When it says show clearly how you work out your answer, the examiner is expecting to see data taken from the graph, so annotations on the graph. They're expecting to see an equation written down, and they're expecting to see your answer and then rounding if it needs it. If you just do it in your head and bung down the answer, you're not going to get the marks. Okay, it says give the unit. I'm going to do that first because that's 1 guaranteed mark out of 4 that I am not going to miss by forgetting. Right, up to the graph. We're doing the section of graph labelled X, so we're starting here, finishing here. So that's from 2 up to 6 seconds. So my time is 4 seconds. I'm just writing that next to the actual question. My initial speed is 10 meters per second. And my final speed is 50 meters per second. So just off the bottom of the screen there, that's what I've been writing down. Okay, so I've now got at least a couple of the marks, because I've got the units, I've got the data. Right, I'm going to show them that I know the equation, and that I can substitute into it correctly. Then just write the answer down on the answer line. So that's an example of a question where you've got to be really careful, because if you're good at maths and good at graphs, you could probably have done that question in 10 seconds in your head. But that's not what the examiner is asking you to do. They're asking you to show clearly how to get the answer. Question 4. Okay, you've got a bit of recall to do for question 4b. Okay, let's look at our information. Crane on a barge, lift a girder, carries it along a river. Don't really care about the context. The girder has a weight of, they're given as a force, and they're given as a height or a distance. Calculate the work done in lifting the girder. Write down the equation you're going to use. Okay, work done equals force times distance. We did that quite a while ago. Show clearly how you work out your answer and give the unit. Okay, work equals, there was a force of 1 million, distance was 15, so that was 15 million joules. And that's fine, you can write it as 15 million joules there if you want. I'm going to say 15 megajoules, because 1 megajoule is 1 million. But if you wrote 15 million joules, that's fine, because your unit and your number match. You could have written 15,000 kilojoules if you wanted. That's also correct. Right, on to the velocity time graph bit. We've got the motion of the barge after the girder has been lifted. Again, context isn't really that important here. So let's have a look at what they're actually asking us. Well, from A to B, we've got stationary. From B to C, you can see that the velocity is increasing. It's not constant acceleration. You know, it starts off, if you look at the slope is starting off quite shallow, and then it's getting steeper. So the acceleration is increasing at that point. From C to D, it looks like the acceleration is reasonably constant. That looks like a reasonably straight line. D to E, we've got a constant velocity. And then from E to F, we've got a deceleration. But again, the deceleration is not constant because it's not a straight line. It starts off very steep, and then it gets shallower towards the end. So this is very much a higher tier question where they're giving you curves in the graph. And this is more realistic to what a velocity time graph would look like for a real situation. So, describe the motion of the barge over this period of 7 hours. You must refer to the points A, B, C, D, E and F in your description. Okay, so let's just take them a section at a time. So, A to B, stationary. Velocity is 0. I say B to C, acceleration is increasing, and then C to D, greater acceleration. So I've shown that I know that from B to C and from C to D are both acceleration, but that I know that the acceleration is increasing. Right, the next bit was D to E, that was a constant velocity. Of, let's see, that was 0.4 meters per second. Finally, E to F, decelerating, but not at a constant rate. It starts steep, ends shallow, so the deceleration is getting smaller. And the mark scheme says that if you have made your points clearly and you've covered the whole graph, you can have 5 marks. I've not written mine as a paragraph of information because that's not really what the examiner is going to be looking for. They're going to be looking for, do you know the physics behind it? So to write it in a kind of list form like that is acceptable on a physics paper.